Hi everyone, today I will teach how to simplify expressions involving indices for additional mathematics or mathematics subject. Now let's recap the basic knowledge of index. Alright, so whenever we are trying to multiply the same digit or same number again and again by itself, we can write in the form of index, where in this case it will be 2 to the power of 4. The 4, it's because the digit 2 is being multiplied by itself 4 times. Okay, where we can name this digit 2 to be base, where this 4 is known as index, exponent, or power. Alright, this is the basic things that we need to. There are few rules that we need to remember when we want to solve questions that involves indices. So here I've listed 9 rules. When rule 1, it is stated that whenever we want to multiply indices that involve the similar base with different power, we can simply write down the base and then add up the power together. Where in this situation, the base will be a, which is similar to each other, and the power is different, so we can write the base, which is a, and then add up the power together, which is m plus n. It's pretty simple. Okay, where in rule 2, when we want to divide the indices that involves the same base again but with different power, we can simply write down the base one more time and then minus the power to each other, which means we need to minus the first power, and then we need to write down the first power and then minus with the second power, the subsequent power. In this situation, it will be a and then m minus with n. It's pretty straightforward. Sometimes in questions they won't be writing these division, but instead they will be writing in the form of fraction. We need to know that even though they are writing in the form of fraction, it means that a to the power of m always is being divided by a to the power of n. So the same rule apply, where we can write it as a to the power of m minus n. When it comes to rule 3, when we want to expand a bracket of an indices that involves a power, we can just add up the power together with the power of the indices. So in this situation, it will become a to the power of m multiplied with n. Pretty straightforward. Okay. In rule 4 is slightly different than rule 1 and 2, where in this situation the power is similar, n and n, alright, where the base is different. So what we can do is we can factorize the power out, and then we can multiply a and b together. In this situation, a and b will be multiplied together, and then we can just put a bracket, and then it will become to the power of n, because the power is similar to each other. The same concept applies to rule 5, but this time it is being divided by each other. The same thing, the base is different, but the power is similar. So we can just factorize the power out, so it will be a over b to the power of n. Rule 6 is very important, where we need to know that anything to the power of 0 is always equals to 1. So in this situation, I simply wrote as a to the power of 0 equals to 1. In reality, anything doesn't matter. For example, x to the power of 0 is still equals to 1. For example, number 5 to the power of 0 is still equals to 1. It's pretty straightforward, and students need to know this very well, because we will be applying this rule very often, and students will get stuck whenever they want to solve a question. Whenever they see the power of 0, they forgot this rule completely. So it's very important for every student to remember this rule. Rule 7 is pretty simple, even though it seems to be complicated. Whenever we see an indices that involves a power that has a negative in it, or doesn't have a negative, doesn't matter, we can change it to become fraction. How we can do that? Okay, for example, this situation, a to the power of negative n. Okay, we can also write it as in the form of fraction, right? We can always move this a to the power of negative n to be denominator by just changing the sign of the power. So it will become 1 over, when you want to move this a down, it will become a to the power of n. Just the sign changes. The same thing applies when you want to make a fraction to become indices. For example, 1 over a to the power of negative n. Okay, this negative, okay, if you want to remove this negative, you can simply move this a to the power of negative n to become denominator. So it will become a to the power of n. You just need to change the sign. Pretty straightforward actually. Rule 8 and Rule 9 is also quite similar, where we can change an indices that involves fraction as its power. We can change it to root form or to the power of root and power form. Alright, so I'll show you an example here. So whenever you see a digit 1 as a dominator, a to the power of 1 over n, we can always change it to a root, and the power of the root will be the denominator. For example, a to the power of 1 over 2, which means it is equals to a, and then it will become square root. Okay, to be square root, we can always write it as just like this by itself. We don't need to write it as something else. Okay, whenever we see a to the power of 1 over 3, we can change it to be cube root a. Okay, it's pretty simple, right? When it become a to the power of 1 over 4, we just need to write it like this, to the power of, root to the power of 4. Wherever in rule 9, we can use the same method, but we need to add one more thing, the m as its power. Okay, so for example, a to the power of 3 over 2. Okay, what we can do here is write down the square root first. A square root 2 because of 2 here, and then you need to add the power 3. Pretty straightforward, right? So for example, a equals to 7 over 3. The same thing again, a cube root 3. Why? Because the digit 3 here, and then to the power of 7. Okay, it's very simple. Students need you need to practice on questions that involves all these rules, so that we can familiarize ourselves with on how to solve questions that involves indices. Now let's try example 1. In example 1, they ask us to simplify each of the following. For question A, it is written as x to the power of 5, open and close bracket, to the power of 3. So according to rule 3, if I'm not mistaken, yes, according to rule 3, we can just multiply this 3 together with this 5. We can just expand the bracket. So it will become x to the power of 5 multiplied by 3. It becomes 15. Very simple, right? And B, it follows, since it's multiplied to each other, it follows rule 1. So since the base is the same, so we can just write down the base and then 7 plus with 9. So we will be getting x to the power of 16, if I'm not mistaken. Yes, 16. Okay, so see the same thing. Now we need to divide. So when we want to divide, we need to minus the power when the base is similar, right? So write down x, 5 minus 8. So it will become x to the power of negative 3. Very simple. All right, and now, so this thing is, it seems to be complicated for D. I'll write it here. So square root x to the power of 10. We can also change the square root to become a fraction, correct? So it will be x to the power of 1 over 2, right? And then to the power of 10. Just write the power of 10 outside. It's okay. Or we can write it like this also. X to the power of 10, and then open close bracket, change this square root, because it's square root, correct? Change the square root to become fraction. It will become 1 over 2. This one is based on rule 8. Okay, I just taught you just now, right? Based on rule 8, we can change vice versa. So we can change the square root to become indices. You can change the indices to become a root. It's the same thing. So now, since the 1 over 2 become the power of this bracket, we can just add we can just multiply with the number 10 with 1 over 2. So it will become x to the power of 5. Pretty straightforward. E, the same concept again. Square root 3, x to the power of 6. So what we can do here, write x to the power of 6, and then open close bracket, convert this cube root to become the power of the indices. So into the cube root, it will become 1 over 3 when you want to change to the fraction of the power, correct? So when you want to multiply together, it will become 3. Sorry, it will become 2. So 2 times 3 is 6. Yes, correct. So it will become x to the power of 2. It's very simple. Okay, it's not that hard actually. And F is x negative 1 to the power of 2 multiply with x to the power 1 over 2 to the power of 8. Let's do one at a time. So the bracket, we can just multiply negative 1 and 2. It will become x negative 2. Multiply with, we can again multiply this together. So it will become x to the power of 4. Since it's multiplying to each other, correct? X and multiplying to another x is the same base, correct? So when we want to multiply, we can just add up the power together. So negative 2 plus with 4 is going to give you x to the power of 2. Negative 2 plus 4 is 2. Easy, right? Not that hard. Let's try for g. G might be a little bit lengthy. So let me rewrite again. 9x8 y to the power of negative 4 times with cube root 8x 6y to the power of negative 3. So first, let's change the square root and cube root to be in the form of indices, to become the form of exponent or power. So the square root, we can just put a bracket for everything first inside the square root. 9x to the power of 8, y to the power of negative 4, close bracket. Since the square root, if we change it, it will become to the power of 1 over 2, correct? So just write it like this. So again, convert everything inside here, rewrite again in the form of bracket, inside bracket, y to the power of negative 3, close bracket. Since it's cube root, it will become 1 over 3. So what we need to do now, just multiply everything inside. So 9 to the power of 1 over 2, make sure to write for everything. So x, it will become 8 times 1 over 2, it will become 4, correct? So y, negative 4 times 1 over 2 will become negative 2. Okay, so far so good. So multiply with 8 to the power of 1 over 3, right? 1 over 3. And then x, 6 times with 1 over 3, it will become 2. Yes, 2 times 1 over 3. Yes, correct. And then y, negative 3 times with 1 over 3, it will become negative 1. It's not that hard. It's very, very simple actually. So I think we can solve actually everything is being multiplied to each other. 9 actually times with x to the power 4 times with y to the power negative 2, and then times again with a to the power 1 over 3, which means we are just multiplying every single digit to each other. Okay, even though despite the symbol times is being written here, that's what we need to understand. So 9 to the power of 1 over 2, if you plug in inside your calculator, is going to give you 3. Or on the other word, you can just like square root 9. Square root 9 is 3. Correct, we can just write it as 3, and then we can multiply with a to the power of 1 over 3. A to the power of 1 over 3, which means we need to cube root this digit 8, whereby it is going to give you 2, correct? So we can just multiply with the number 2, because this thing is going to give you 2 when you try to plug inside calculator. So we can just multiply this number and this number. Okay, now number and number done. Next, let's try to multiply x with x. So x to the power of 4, when you want to multiply with x to the power of 2, what you need to do, since the base is the same thing, we just need to add up the powers together. So 4 plus with 2, right? Close bracket and then open bracket one more time. Again, y and y is the same base, we just need to write it as y. Negative 2, it will become it plus with negative 1. Close another bracket. So let's try to solve everything one shot. So 3 times 2, it will become 6. X, 4 plus with 2, it will become 6 again. And then y, negative 2 plus minus is minus, right? So negative 2 minus 1, it's going to give you negative 3. So that is the answer for G. I hope the solution that I gave you to simplify the questions involving indices is pretty straightforward. It's pretty easy actually for students to do it. Now let's try to solve example 2, where it is written as the first one, 3xy to the power of 2, and then multiply with square root x to the power of 4, y to the power of 6 over 2x to the power of 4, y to the power of 3, and then square everything to the power of 2. Alright. So first, we need to expand this bracket with the power of 2 here. So what we need to do is we need to attach this power 2 to each of the base here. There are 3 different base, correct? So the first one, it will become the first one is 3, digit 3, so it will become 3 to the power of 2, and then x to the power of 2 followed by y to the power of 2. Very simple. And then multiply with, we always, whenever you see any question that involves square root or cube root or anything that involves root, we need to convert that root to become indices or to become power of something. So what we need to do, rewrite everything inside this root inside bracket in the form of bracket here. X to the power of 4, y to the power of 6, close bracket, and then it will become the power of 1 over 2, y to the power 1 over 2. According to the rules that I taught you just now, whenever we are trying to convert a square root, okay, square root, we need to always write it in the power of, in the form of 1 over 2 to the power of 1 over 2, and then we just need to divide everything together, and then again we need to expand this bracket, so it will become 2 to the power of 2, x to the power of 4 times 2 is 8, y to the power of 3 times 2 is 6. Okay, let's solve the dominator part of the fraction. So we need to expand this bracket first, right? I forgot. Okay, so 3 to the power of 2 is 9. So 9x square y square times with x. Oh, wait, maybe I'll write it properly. Times with x to the power of 2. Because 4 we need to multiply with 1 over 2. It's going to give you 2. And then y to the power of 3, as 6 multiplied with 1 over 2 is going to give you 3. And then we can rewrite again. 2 to the power of 2 is 4, x to the power of 8, y to the power of 6. Now rewrite this 9, and then we can multiply x and x together, right? Since it's the same base, so it will become x. 2 plus with 2 is going to give you 4. And then y and y we can multiply together, write y, and then we just need to add up the base together since it's a multiplication. So 2 plus 3 is 5. And then rewrite again, divide by 4, x8, y to the power of 6. And then equals to, now we can divide 9 with 4. 9 over 4, we can just write it as 9 over 4. Okay. And then x to the power of 4, when we are trying to divide with x to the power of 8, we just need to minus the power with each other. So x 4 minus 8 is going to give you negative 4. Again, y we can write it because it's the same base, right? And then 5 minus with 6 is going to give you negative 1. It's pretty straightforward. Okay, everything that I'm solving here, I'm using the rules that I taught you just now, from rule 1 to rule 1, from rule 1 to rule 9. Okay, so in this situation I use the addition rule and division rule and expanding the bracket, that rule. So rule 3, from rule 1 to rule 3 if I'm not mistaken. Example 3 is slightly different, but is given that 36 times x to the power of 4, and then open close bracket to the power of 2 over 8x square multiplied with 3x, which is equals to 2 to the power of a, 3 to the power of b, and x to the power of c, where they ask us to evaluate a, b, and c. So which means we need to simplify the equation on left hand side here, so that it matches the equation on right hand side. So in order to do that, let's try to simplify this equation first on left hand side. So the first step is, let's try to rewrite first, let's rewrite the equation first. 36x to the power of 4 open close bracket to the power of 2, 8x square times with 3x. Alright, so now first we need to expand the bracket. So 36, we need to write it as to the power of 2, 36 to the power of 2, and then x to the power of 8, because 4 need to multiply with 2, so it is going to be 8. And then divide by, since we need to times together 8 and 3, we can times together, which is going to give us 24. And then x and x we can times together also by just adding the power. Here the power is 2, here the power is actually 1, right? So 2 plus 1 is 3. It's pretty straightforward, not that hard. So 36 square divided by 24 is going to give us 54. Alright, and then x to the power of 8, which is divided by x to the power of 3, we can just simply write it in the form of 8 minus 3. So 8 minus 3 is going to give you 5. Now when we try to compare this, okay, when we try to compare this with equals to 2 to the power of a, 3 to the power of b times x to the power of c, we can realize that only x matches with the one in right hand side, but the number 2 and 3 doesn't match with 54, which means we need to split this 54 to be in the form of 2 and 3. The power we don't know, correct? So there are a few methods how we can do this. Okay, the method that I personally prefer is try to take 54 and then divide by 3 first. Take the highest digit. Okay, divide by 3. If we divide by 3, we're going to get 18, and then keep on dividing. We can try to divide 18. Can we divide by 3? Yes, we can. Keep on dividing. So we are going to get 6. 6, can we divide by 3 one more time? Yes, we can. We are going to get 2. And then 2, we need to divide by, we can't divide by 3, but we can divide by 2. Correct. So we just need to try to divide by 3 and 2 again and again and see until we get the digit 1. So now we can see that we need to multiply 3 digit 3 times and then multiply with 2, which means if we multiply 3 times 3 times 3 times 2, we're going to get 54. That is the terminology behind this. We need to multiply each other to get 54. Make sure the number that we get at the end is digit 1. That is the most important thing. And you always need to divide by the number that we want. We want 2 and 3, right? So we need to keep on try to divide by digit 3 and digit 2. Okay. Now let's try to divide by 2 instead of 3. Okay, 54 divided by 2 is 27. Oh, sorry. Everything messed up. Sorry. I accidentally deleted those things. Never mind. So I'll rewrite again. 54. I tried to divide by 3 just now. I got 18. And then divide by 3 again. I got 6. And then divide by 3 again. I got 2. And then divide by 2. I got 1. That's it, right? So wait, I want me to. So when we try to multiply these to each other, we're going to get 54 at the end. So which means it matches up, which means 3, we need to multiply 3 times, which is 3 to the power of 3 times with 2 to the power of 1, we're going to get 54, right? This is by starting to divide with 3. Now let's try to divide with 2. 54 we can divide by 2, right? We are going to get 27. 27, can we divide by 2? Yes, but we'll be getting decimals. We don't want decimals. So since we cannot divide by 2, we try to divide by 3. So 27 divided by 3, we're going to get 9. So 9 divided by 3, we're going to get 3 again. So 3 divided by 3 again, we're going to get 1. So as you can see, it's the same principle and same method that works again and again. So when we try to multiply this thing, we're going to get 54. So it doesn't matter you start with dividing 3 or you start with dividing 2, but make sure the end digit that you are getting is 1 so that you can get whatever that you want. So in this situation, it is 2 to the power of 1 and then multiplied with 3 to the power of 3. Why 3 to the power of 3? Because 3 is being multiplied with each other 3 times. Okay, so at the end, you're going to get 54. So what we can do now, we can plug this value 2 to the power of 1, correct? So 2 to the power of 1 times with 3 to the power of 3, in which we're going to get 54, correct? And then x to the power of 5. And then when we compare with right hand side of the equation, which is 2 to the power of a, 3 to the power of b, and x to the power of c, we can evaluate a, b, and c already, whereby a is equals to 1, b is equals to 3, and c is equals to 5. It's pretty straightforward actually. Now let's try to do example 4. Given that ax to the power of 2 over b to the power of 5 minus x multiply with b to the power of y minus 4 over a to the power of y equals to a square multiply with b to the power of 4, and they ask us to evaluate x and y. It's similar, the method is pretty similar to example 3. Okay, let's try to simplify this first. Okay, first we need to expand the bracket where it is going to be a to the power of 2x, since we need to multiply x and 2, and then rewrite everything else first. B to 5 minus x times with b to the power of y minus 4. Sorry, it's pretty messy. Y minus 4 over a to the power of y. So what we can do is we can simply rearrange. Since it's multiply, we can just like put it like this, correct? A to x and then multiply with by minus 4 over b 5 minus x multiply with a to the power of y. We can do that. So a and a we can divide together, correct? So wait, before that, let me erase that to avoid confusions. Okay, a and a we can divide together since it's the same base. So a, the power we need to minus with each other, correct? So 2x minus with y, and then b we need to minus the power, because b and b the base is the same. So y minus 4 don't forget when you minus, don't forget to put bracket 5 minus x, because it's not a single unknown, a single number, it's like multiple equation as the power, correct? So we need to put a bracket, don't forget to do that. So it's equals to a 2x minus y, and b y minus 4 minus 5, and then minus minus is going to be positive, correct? So it is going to be y plus x, and then minus 4 minus 5 is going to give us minus 9. It's pretty straightforward, I believe. So now we need to compare with a to the power of 2 and b to the power of 4. So this 2x minus y we can compare with 2, correct? With digit 2, because a and a the base is the same, and then we can just compare the power to each other. So 2x minus y equals to 2, the first equation. And second equation, we can just compare y plus x minus 9 with digit 4. So y plus x minus 9 equals to 4. This is equation 2. So now we can solve each other by doing simultaneous equation, by solving through simultaneous equation method. So what we need to do now, we need to choose which equation that we want to make it as a subject. So based on my preference, I'll choose the equation that has lowest power. In this situation, the lowest power is 1 for both equations, correct? So I can choose either equation 1 or equation 2. So the next step I'll follow is I'll try to pick up the equation that has the least digit as the number in front of the constant. The constant is y and x, correct? In front of y is 1, and in front of x is 1 as well. But here in front of x is 2, and in front of x is negative 1. So the lowest digit is 1 in equation 2. So I'll be choosing equation 2 to make it as a subject. So rewrite y plus x minus 9 equals to 4. And then I can choose either y or x to become the subject of this equation. So maybe I can choose y for now. So y equals to 4, and then plus with 9, and then minus x. So it's going to give me 4 plus 9 equals to 13 minus x. So this is equation 3, correct? Since I derive equation 3 from equation 2, so I need to substitute equation 3 inside equation number 1. So let me rewrite equation number 1. 2x minus y equals to 2. Now instead of y, I need to substitute these values here inside this equation number 1. So 2x minus with 13 minus x equals to 2. Alright, so it's going to give me 2x minus 13 plus with x equals to 2. Alright, so it's going to give me 3x equals to 2 plus with 13, which is 15, correct? Okay, 2x minus 2x plus x is going to give me 3x, and then if negative 13 I bring to right hand side of the equation, is going to be positive. So 2 plus 13 is going to give me 15. So x is equals to 15 over 3, which is equals to 5. Alright, so I found the value of x, but I need to find the value of y. So what I need to do now is take the value of x and substitute inside the equation number 3 that we derived just now. So let me rewrite first. So y equals to 13 minus x, whereby x is where x we found it as 5, correct? So 13 minus 5 is going to give me 8. So I found the value for x and y already. So that's the method on how to solve this. Alright, example 5 is a little bit tricky, where they ask us to simplify 1 plus x to the power of 3 over 2 minus 1 plus x to the power of 1 over 2. So here we need to split this 3 over 2, so it becomes 1 over 2 plus with something else. So we can write in the form of 1 plus x, 1 plus 3 over 2, sorry, not 3 over 2. 1 plus 1 over 2, why? 1 plus 1 over 2 is 3 over 2, correct? So minus with 1 plus x to the power of 1 over 2. So here, this part, let me rewrite here first. 1 plus x, 1 plus 1 over 2. If I let 1 plus x is equals to a, so it's going to give me 1 plus 1 over 2. Correct. So according to the rule 1 that I explained earlier, if we try to do reverse calculation, we can split this to become a to the power of 1 multiplied with a to the power 1 over 2. Correct. So it's going to if we try to simplify this, it's going to give us a 1 plus 1 over 2, which is 3 over 2. So if I simplify something like this, if I split something like this, at the end I can factorize this part, this where it's 1 plus x to the power 1 over 2. So let me rewrite again. So since if I want to substitute a with 1 plus x again, so it's going to give me 1 plus x to the power of 1 multiplied with 1 plus x to the power of 1 over 2. Let me rewrite here. So 1 plus x multiplied with 1 plus x to the power of 1 over 2 minus 1 plus x to the power of 1 over 2. So now what we can do is we can simply factorize this thing. 1 plus x to the power 1 over 2 is, so when we want to factorize this 1 plus x to the power 1 over 2, the remaining will be this, correct? 1 plus x and then minus with 1. Why minus with 1? When we are factorizing the entire thing, we need to leave digit 1 here. Alright, so try to expand this one more time. When we expand this bracket, it's going to give us this equation. Alright, so that's how we need to verify whether we did factorize it properly or not. So once this factorization is done, so 1 plus x to the power of 1 over 2, we can solve this. If you open bracket, 1 minus 1 is equal to 0. We just need to multiply with x. Correct. Am I right? So if I want to rearrange this equation, it's going to give me x open bracket 1 plus x to the power of 1 over 2. So this is how we can simplify the question in example. So please like this video and subscribe this channel, which is RG Tutoring, to stay updated with more videos that I'm going to upload in future, which will be related to additional mathematics and mathematics.